The following is the video solution from JSDT Solutions. Question 1 says, truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. So we have the distance traveled in kilometers, and those are our x values, and the amount of rest time in minutes, which are our y values. And the first question 1.1 says, determine the equation of the least squares regression line for the data. So we know that that equation looks like this. It's the equation of a straight line. Y is equal to a plus bx. And with this, all we really need to find here is the value of a and the value of b. So let's go ahead and put our information in our calculator. We'll first go to mode, and then we'll see a couple of options, and we just need to go for the option that says stat. And then we're going to go for the option that says a plus b, since we have a bivariate data set. So I'm just going to get rid of these, and what we're going to do is substitute the x values in place of x and the y values in place of y. Remember that you have numbers on the side, so it should end at 8 numbers. And then once you have your data recorded, you can go ahead and press AC, Shift, and 1. And then we'll see some options: type, data, sum, VAR, and regression 5, which is REG, and we're going to go for that. Okay, so we can see the value of A, and A is equal to negative 23.85 rounded off to 2 decimal places, and then B. So you can just press Shift 1 and then B. So we can see B is now 0.23. Now you're going to still have to go to regression again, but it's fine. You still follow the same steps to find B. Okay, so that concludes that the equation of our least squares regression line is y is equal to negative 23.85 plus 0.23x, and that is our answer. Question 1.2 says, if a truck driver travels 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. So we can see that this is the distance traveled, and from our table, the distance traveled are our x values. So we're going to take our least squares regression lines equation and substitute in place of x. Since we have been given an x value, we'll substitute that 550 so that it can give us the y value, which would be the amount of time that the truck driver would rest for. So we'll say y is equal to negative 23.85 plus 0.23, and then in place of x, that is going to be 550. And let's go ahead and see. And when we substitute, we get a y value of, and we can do calculations here still perfectly fine, 102.65 minutes. Okay, so that will be the time that this truck driver would spend resting. Okay, so that is our answer, and moving on to the next question. Question 1.3 wants us to write down the correlation coefficient for the data. So that is that value of R that we have in our data. Okay, so on our calculator, we can get rid of this by saying AC. And then if you say Shift and 1, then our data will pull back up again. And you need to go for regression again. And then you'll see that R is your correlation coefficient, which is 0.98. And this is very strong. You see how close it is to 1. Okay, but they didn't really ask us to comment on its strength, so this is our answer. Question 1.4 says, interpret your answer in question 1.3. So you see that in 1.3, we found the correlation coefficient, and it's 0.98. So we need to interpret what that means about our data. So remember that we have a bivariate data set. So we are looking at whether these two variables are related. Does the distance traveled affect the amount of time that the truck driver takes to rest? Now, saying it like that, of course, you can see that, of course, it does affect it. If you went for a longer drive, you would require more rest. But based on the correlation coefficient, we're going to have to comment on this. So we're going to comment on the strength and the direction of the data. So because it is 0.98, that is quite close to 1, okay, which suggests, and it's past 0.9. So it suggests that this is going to be a very strong correlation, but also notice that this number is positive. So when we are commenting on this, we're going to call this a very strong positive correlation. Okay, so this is just speaking about the relationship between the two values that we had, the two variables we have. Okay, so you always say the strength and then the direction. I will go ahead and leave a scale, correlation coefficient scale, so you can use that as a reference. And remember, in this scale, I'm not really considering whether it's positive or negative. We're just using the absolute value of R. Okay, so remember, just from 0 to 0.1, if it's greater than 0 but less than or equal to 0.1, it's so small you can barely even consider that there is any correlation between the two variables. Okay, so this is our answer. It's a very strong positive correlation. And moving on to the next question. Question 1.5 says, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. And the first question is to find the mean amount of money he spent at the shop. Now, you can't just check what the second question is just to see whether it is worth manually calculating this mean or using the calculator. And from the next question, you can see that they're asking for standard deviation. So it's best to actually just use the calculator to find this mean. So on our calculator, we are going to go ahead and remove this data so you can put it back on comp. So just press mode and then 1. And then we're going to go ahead and press mode. Then you're going to go for the stat option again. But this time, we are not taking a data set that has two variables. We're taking a one variable data set, the money spent on refreshments. So we're going to go ahead and go for 1 VAR. And then let's just put down our values in here. And then to find the mean, we'll press AC, Shift, and 1. And then we'll see 5 options, but we'll go for number 4, which says VAR. Okay, so variable. And then you are going to see a couple of options, just 4 options, and we need to find the mean. So the mean of the X values, and that would look like that. Okay, so 150. There we go. And moving on to the next question. Question 1.5.2 says calculate the standard deviation for the data. So on our calculator, we are going to press Shift 1, and then you'll see your options again. Go for VAR, and this will be the standard deviation. It's the standard deviation of the X values, the single variable that we put in. Okay, and that standard deviation is about 50 Rand and 40. Okay, it's not going to be 49 cents because it's going to round up. So it's going to be 0.50, rounds up to 50, so 2 decimal places. And that would be our standard deviation. And that is our answer. Question 1.5.3 says, and how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? Okay, so this is specifically 1 standard deviation, an amount that was less than 1 standard deviation below the mean. So it is already a standard deviation below the mean. So just looking at it as a graph, let's say you had your mean. Okay, your mean is maybe here. That's the mean value. And we know the mean already. It is 150 Rand. Okay, 150. So we would first have to look for the amount exactly that would be exactly 1 standard deviation below the mean. Okay, and how we find that is it's a standard deviation below the mean, meaning whatever your mean is, go a standard deviation below this. So minus a single standard deviation. Okay, or we can just leave it like that. So that will be 150 minus 50.50. So we can see that that is about 99.50. Okay, now they're specifically asking for, we found out what 1 standard deviation below the mean looks like. It's that amount. And we need to look for values that are less than this. Okay, so in our values, we're really just going to look for values that are less than 99.50. On a graph, you're looking for exactly 1 standard deviation away from the mean, and you're looking for all the data points that lie below here, which means that the driver would have spent a pretty low amount, which could be a good thing because, That means you spent less on those days. But they probably wouldn't be a lot. And let's go ahead and see how many that would be. That would be the ones less than 99.50 cents. That's just 50. Okay, there was only one day that the truck driver actually spent that amount. So since it was only one, okay, or one stop, we're going to answer them. They said, how many stops did the driver spend? An amount that was less than this, and this was just one stop. Okay, that is how many stops. And that is it for question 1.